Captions in English, please. So this is the second video of chapter 8, and we will introduce the molar mass, or the mass of 1 mole of elements. So we were able to determine the mass of nails, the weight in pound, that we would need to purchase based on the number of nails we wanted. You remember we wanted 200 nails, and using the fact that there is 12 nails in a dozen, and then we know the mass of a dozen, then we were able to find the mass of 200 nails. And by, weighing nails, we were able to count the number of nails. So how do we equate the number of atoms in a substance to its mass? So we need another conversion factor to equate the mass of 1 mole, similar to the way that we found the mass of 1 dozen nails. So here we had given the mass of a dozen nails. And so for us now to, given that we can count the number of atoms and convert them into a number of moles, now we need to know the mass of 1 mole of, element, for example. So here, these pictures have the same number of nails. There is a dozen in each case. But the weight of 1 dozen nails will change depending on the type of nails we have. So if you have long, heavier nails, the mass of a dozen nails will be larger in the case of the left nails compared to the right nails. A dozen of smaller nails here will have a smaller mass. And so it's the same with atoms and elements. These pictures have the same number of atoms. They represent 1 mole. So in each of these samples, you have 1 mole of atoms of sulfur on the left and carbon on the right. So you have, in both cases, 6.022 10 to the 23rd atoms of sulfur on the left and of carbon. But the weight of 1 mole of atom will change depending on what element we have. You can see that 1 mole of carbon has a mass of 12.01 gram, when 1 mole of sulfur has a mass of 32.07 grams. And that's, I want to add, that's because the size of a sulfur atom is larger than the size of a carbon atom. Each sulfur atom is heavier, so when you take a mole of it, you will have a larger mass. So how molar mass and atomic mass are related? So we know that the atomic mass unit is defined as 1/12 of the mass of a carbon-12 atom. The isotope carbon-12. If you take its mass and divide it by 12, you get the atomic mass unit. And in grams, it's 1.6605 10 to the negative 24 grams. And so the atomic mass is found on the periodic table. We've seen that how the numbers that are below the names or below the symbol that have decimals are the atomic mass of elements. So if you look at your periodic table and find the copper atom, you can see that it has an atomic mass of 63.55 atomic mass unit. So the molar mass, which means the mass of 1 mole of atom, and would have a unit of grams per mole. So that's what it is. The molar mass is the mass of 1 mole of atom in grams. So if one atomic mass unit is 1.6605 10 to the negative 24 grams, what is the molar mass of copper? So we have 63.55. So in your calculator, you can do that. 63.55 atomic mass unit. That's the mass of 1 copper atom. If you multiply this mass in atomic mass unit by the number of grams per, atomic mass unit, you get, so you multiply this by 63.55 atomic mass unit by 1.6605 10 to the negative 24 grams. So that's the mass in grams of 1 copper atom. And so now to know the molar mass, you need to multiply that by the Avogadro number, 6.022 10 to the 23rd atoms, because earlier we had the mass for one copper atom. Now we have the mass for a mole, and that's 63.55. So you get the same number here, because one copper atom has an atomic mass of 63.55 atomic mass unit. Then 1 mole of copper atoms will have a mass of 63.55 grams. If you calculate that, that's what you end up with. So that means the molar mass of copper is 63.55 grams per mole. So those numbers that you find in the periodic table are also the molar masses of your elements. It's the same number. So the mass of 1 mole of atoms changes for different elements, as we saw with the atomic mass. For example, carbon, it's 12.01 grams of carbon for 1 mole of carbon. And in 1 mole of carbon, we have 6.022 10 to the 23rd atoms of carbon. If you look at sodium, Na, 22.99 grams of sodium represent 1 mole of sodium. 6.022 10 to the 23rd atoms of sodium. So these numbers that you find on the periodic table that we called average atomic mass, now you can take them as the molar mass of your elements. So calculate the number of moles of carbon in 80.2 grams of carbon. So let's practice using that molar mass. So this molar mass, as you can see, will allow us to change the grams of carbon into moles. So we have 80.2 grams of carbon, and we want the number of moles of carbon. And if you look at the periodic table, it says that the mass is 12.01 grams per carbon. So written as an equality, it's 12.01 grams equals 1 mole of carbon. So we have grams of carbon, we want moles of carbon. So because we start with grams of carbon, the equality will be written as a conversion factor with the grams on the bottom, because we want to cancel grams, the given unit. So the solution will look like this. You will take your given amount of 80.2 grams of carbon multiplied by 1 mole of carbon over 12.01 grams of carbon. This way the grams of carbon cancel. And you do 80.2 divided by 12.01, and that's 6.677768, etc. That's the calculator answer. Here we have 3 sig figs in the given amount, so we need to keep 3 sig figs in the final amount. So 6.67, what comes after the 7 is another 7, so you need to round up, and that's why it's 8. 6.68 moles of carbon in 80.2 grams of carbon. So you see how we've used the molar mass to change the grams into a number of moles. So let's go through another example on how to convert between moles and mass using the molar mass. So calculate the mass of calcium in 4.25 moles of calcium. So here we are given a number of moles of calcium, 4.25. We want to know the mass in grams of calcium. So you need to look at your periodic table and find calcium. And the molar mass of calcium is 40.08 grams per mole. Written as an equality, it's 1 mole of calcium equals 40.08 grams of calcium. So because we start with moles and we want to find grams, we will rewrite this equality as a conversion factor with the moles on the bottom, because we start with moles and we want to cancel the units of moles. So the solution looks like this. It's 4.25 moles of calcium, the given amount, multiplied by the conversion factor with the mass in grams of calcium on top and the mole of calcium on the bottom. This way we see that the moles of calcium cancel. In the calculator, you do 4.25 times 40.08, and the calculator answer is 170.34 grams of calcium. Because we have 3 sig figs in the given amount, we will keep the 1, the 7, the 0. What comes after the dot is a 3. So you run down and you keep the 0. But because it's a 0, you need to show the decimal point. So that's why the final answer is 170 with the dot grams of calcium. So that's the mass of calcium in 4.25 moles of calcium. So let's do some concept check now. The first one, calculate the mass in grams of 40.1 moles of zinc. So we are given the moles of zinc, 40.1. We want to find the grams of zinc. And so look at your periodic table and find zinc and its molar mass. And 1 mole of zinc is equal to 65.39 grams of zinc. So because we start with moles of zinc, we will use the equality with the moles of zinc on the bottom and then the 65.39 grams on top. And we will multiply the given amount of 40.1 moles of zinc times. So the grams of zinc on top and the mole on the bottom, because we want to cancel the moles of zinc, cancel those units and be left with just grams of zinc. So you do 40.1 multiplied by 65.39, and that's 2,622.139 grams of zinc. That's the calculator answer. Because we have 3 sig figs in the given amount, we want to keep 3 sig figs. And so that's going to be rounded to 2,620. Because what comes after the 2 is another 2, so you keep the 202. But you need to change the second 2 into a 0 to show that it's 2,620, right? To show the thousands place and hundreds place and tens place, you need the 0 there. However, you do not show the decimal point because that would make it 4 sig figs, and we need only 3 sig figs. And so that's the amount of grams of zinc in 40.1 moles of zinc. We see that it makes sense, right? Because if 1 mole is 65 grams, you multiply by 40 moles, it's expected to be this large number of grams. Second concept check. Calculate the number of moles of argon equal to 7.30 10 to the 5th milligrams of argon. So we have this mass in milligrams of argon, 7.30 10 to the 5th milligrams of argon. And we want to find the moles of argon in that mass. So because the molar mass is in grams per mole, that means we will need to change the milligrams into grams. So you need the relationship between milligrams and grams. And it says that 1 milligram, so change the milli by its value, and the value of the milli prefix is 0.001, and then rewrite the base unit of grams. So 1 milligram is 0.001 gram. So that will allow us to change the milligrams into grams. And then using the molar mass of argon, we can change the grams into moles. And so if you look at your periodic table, the molar mass of argon is 39.95 grams. And that's for 1 mole of argon. So because we start with milligrams of argon, so we have 7.30 10 to the 5th milligrams of argon. We will multiply by the first conversion factor that will convert the milligrams into grams. And so because we start with milligrams, you want the 1 milligram on the bottom and the 0.001 gram on top. This way, The milligrams cancel. At that point, if you were to calculate this intermediate answer, you would have grams of argon. And so the next step is to change the grams of argon into moles. So you multiply by 1 mole of argon over 39.95 grams of argon. You want the grams of argon on the denominator such that you can cancel units of grams of argon. And you're left with moles of argon, which is the unit you want in the end. So you're ready to do this in the calculator, and it's 7.30 times 10 to the 5th multiplied by 0.01001 and divided by 39.95. And the calculator answer is 18.2728 moles of argon. Because the given amount has 3 sigfigs, the 7, the 3, and the 0, that 0 is significant because we see the decimal point, and it's a scientific notation, so whatever is shown in the decimal part of the scientific notation is significant. So 3 sigfigs, the 1 mole is exact, the 1 milligram is exact, the 0.001 gram is exact. The molar mass has 4 sigfigs, so you want to keep 3 sigfigs because of the given amount. So 18.2728 will be rounded to 18.2, but what comes after the 2 is a 7, so the 2 will become a 3. 18.3 moles of argon. That's the number of moles in this mass of milligrams of argon.